Did you see my video where I broke down and explained how to culture microorganisms? If not, make sure you give me a follow and then go check that out after this video. Because in this video, we're going to talk all about how we use those cultures of microorganisms to investigate the effectiveness of antibiotics. Now remember, an antibiotic is a chemical that only kills bacteria. So we would want to culture some bacteria onto our agar plate. We want to have an even distribution of bacteria all over our agar plate, and then we're going to add some antibiotic and see how effective the antibiotic is. So how do we do that? Well, what we've got is we've got these 4 little discs of filter paper, and the paper is soaked in an antibiotic solution. So one of the first things we want to make sure of is that we use the same volume and concentration of antibiotic. There would be no point using kind of twice the concentration of antibiotic in A compared to B, unless our independent variable was the concentration of antibiotic and we were using the same antibiotic and we're actually varying the concentration. But that would be our specific independent variable. We also want to then measure the size of our zone of inhibition. Well, the antibiotic is going to diffuse out of the filter paper. As it diffuses out of the filter paper, it is going to kill any bacteria, which means the area around the antibiotic disc, the filter paper, where the bacteria are unable to grow and reproduce, that is where the antibiotic is effective. Now, the concentration of antibiotic is going to decrease the further away from the disc you get. So, for example, A here, anything past this point here, the concentration of the antibiotic is so low that it's unable to kill the bacteria. From this point inwards, the antibiotic is effective. And the larger the zone of inhibition, that means the more effective the antibiotic is. Because B, for example, all the way out here, it is going to be a lower concentration of antibiotic, and so the zone of inhibition is larger, and so the antibiotic is more effective. The larger the zone of inhibition, the more effective the antibiotic. But how do I know it's the antibiotic that is killing the bacteria? What if it's just the filter paper? What if we've used toxic paper, perhaps? Well, I'm going to use a control disc. So D here is my control. What D would contain is that it would be exactly the same filter paper, but it would be something like distilled water instead. No antibiotic. And that way we can see that the bacteria are able to grow and reproduce all around D. D is not killing those bacteria. And that allows us to compare the effectiveness of the antibiotic to when there is no antibiotic, and shows us that the antibiotic is killing the bacteria. So there we go.